cybersecurity people are very worried about cybersecurity. So I want to sort of bring down the level a little bit and calm everyone down and tell you a little story about what you really need to worry about. So 2 days ago, I was up fairly early. Nice to be down in Orlando, much nicer being Boston, as you all know, I think. So I went to the concierge and I said, I'd like to go for a walk. And she said to me, a younger woman said to me, we have a map of some walking trails, walking places. And she gave me this map, and it was the blue circle went on International Drive, and the green circle went on another road. And I said, well, those are all on roads. Is there anywhere I could drive to go for a walk, you know, that might be a little? She said to me, not really. Orlando's not a walking city. We actually have the highest pedestrian kill rate of any city in the United States. And I thought, what am I worried about with cybersecurity? So in any case, you have to put things in perspective every once in a while. Needless to say, I didn't venture too far for a walk, but I guess that's something to do with the amount of people driving here that don't know exactly how to drive. We're starting something new here, I think, for ARC and for us in a way. It's very exciting. We're combining some ongoing research that we're doing at MIT, along with some of this has been along with industry, various types of industries. And we're presenting during these sessions, we'll present some academic research, and then we'll have some industry panelists, and we'll do a little bit back and forth. And we have a big room. If it gets tough, we can do it out there on the field. I mean, we want to see this really go on and some hard questions. For me, this conference has been fantastic. It's been a great deep dive into industrial control systems. And the one thing I learned is everything we've thought about so far with regard to cybersecurity that might work in the software domain or that might work in another domain applies equally well to industrial control systems. And so we're seeing the same sorts of concerns. We're seeing the same issues around vulnerabilities, around patching issues, around cyber safety. So today we'll have, I'll do a short introduction to what we're doing at MIT, and then I'll talk about some work we're doing in using modeling and simulation to look at system resilience, patching, and software development. I'm not going to dive too much down in the modeling because the chief modeling expert, James Houghton, is here for the first talk of the second session this morning. And I suspect the session boundaries will be a little bit flexible here. But he's going to present some very nice modeling work that he's done, and I think you'll be able to really connect that to some of the things you've been thinking about. Following me, Key Holmes will talk a little bit on cyber safety, and these are some techniques that have been developed. MIT was tasked a long time ago to look at the Challenger disaster, and there was an analysis developed of that as a disaster, and that analysis has been used since then, and is now we're applying it to cyber safety. And it will also extend to not only looking at past events, but being able to do some prediction or understanding where weaknesses might be inside your organization. So that's going to be a very exciting talk. And then we'll have a panel of industry experts, which we're very lucky to have here today. We'll bring those up, and we'll moderate some discussion back and forth. I encourage you, if you hear something really you want to understand better, or really whatever, I don't mind being interrupted. It's fine with me. We can have a little bit back and forth during, I'm sure, the other speakers. One of the tricks at MIT, I have to tell you, this is a standard trick, especially for PhD thesis defense. You got to get past the first slide. And often that first slide has so many questions that you're stuck on that for a period of time. So you got to pick your title carefully and get past that first slide. But after that, the questions can fly back and forth. During the second part, James will talk, as I mentioned, about the modeling, and Michael Coden, who's working with us as part of the MIT IC3 effort, will describe some of the work that we're looking at with regard to judging the perception of security inside organizations. and the perception not only in your organization, but how you perceive your partners that you're dealing with and so on. And we've done some survey work in this area, and it evolves and talks about metrics to some extent and so on. So that will be also a very exciting talk. And then we will follow that again with a set of industry folks on the panel. So to give you a little idea, the Interdisciplinary Consortium for Improving Critical Infrastructure Cybersecurity, which I never say because IC-Qubit is much easier, but I was able to do it there. We're at a business school. We're looking at issues around critical infrastructure, cyber and physical infrastructure around things like oil and gas, chemical, water. Perfect audience here, as you can see. And there's, to a lot of extent, our initial research, I have mentioned yesterday, I've been at MIT for about 25 years. A lot of my original research is in financial services, risk management, and areas like that, and I've done work in distributed systems. I've looked at insurgencies and state stability and various types of things. A lot of the early research that we have done in cybersecurity had looked at more the software and financial services domain, but I think even more important is some of the areas that we mentioned here. And we're focused not as much on building the best architecture and more so on the management issues, as you can read here. And I'll show the faculty later, but examples of the types of problems we will do, look at data aggregation quality, modeling, simulation, to some extent on architectures. I've already mentioned applying accident safety to cybersecurity, cross-border international policy. We're working with a political scientist, so we look all the way at that end about how we might create policies. We've done a lot of standards work and a number of other areas listed there. Here are some examples of ongoing things. We'll talk about the House of Security, the accident research. We have someone working with us from the computer science department, David Clark, who's an expert in telecommunications and has identified a control point analysis approach to looking at where the weaknesses in your, more or less in your computer supply chain is. He has a number of case studies that start with buying something on Amazon and where does the software come from, where does the machine come from, where do the components come from, how were they shipped, and looking at weak points in that type of control point analysis for cybersecurity issues. I've been looking a lot at bug bounty programs. I've been working with Facebook and to some extent Microsoft and other organizations looking at their programs that are buying vulnerabilities. It sounds a little bit like a foreign idea, but may very well work in industrial control systems too. You don't want the eyeballs necessarily. Problem is you open up a program that says, help me find my faults, then you get eyes looking for faults. But it's been a practice for a long time. I remember 20 some years ago, Reuters had a bug bounty program for their data. And if you used their data and you found an error in their data, you called them and you got, I think at the time it was about 25 pounds. And there were people just making a living off of doing that. And they were essentially working remotely for the information company. We do some tipping point analysis. We'll address that in our modeling and some simulation. We have a new project starting up. We have some very good, a lot of young, exciting energy going on. I just wanted to give you an idea. These are some students coming in for a 1.5-year program, and they've decided to tackle risk mapping for the electric operator, looking at the sensor ecosystem, doing equipment risk mapping and operational mitigation strategy. You know, come, if you want to know what all this means, come get involved, join us, that type of thing. And these students are outrageous. They're just, we asked them to take a look at grid situations. We have I should mention we have a number of partners that have joined recently. Our center is about 4 months old. We'll have a major launch with a representative from the White House, the governor, president of MIT, and other parts of MIT coming together on March 12th. Those who have joined are State Street, Schneider Electric, New York Power Authority, Morgan Stanley. We're working with Masdar in the UAE. We're working also with Singapore. There's 4 or 5 other members I haven't mentioned as of yet, but if I recall them during the talk, I'll spout them out. Next9 is also a member, and I'll remember the rest are out. Interdisciplinary, just to give you an idea, I'm not going to go through all these people. Some of the names might be familiar. Somebody like Andy Lowe is in the paper pretty regularly as a more of a financial quant. He's well known for his fair market analysis and in financial services. Key, I notice your name isn't on the list. Oh, there it is. Yes, it is. You're relatively new, joining the center. The director, Stuart Madnick, actually is overseas. Michael and I are associate directors, and you can see political science, engineering, so on and so forth across the board. All right, so any questions on ICCube, what we're doing? This is just to give you an idea of why we're here. We had some discussions with the ARC folks. They said, you know, our folks are interested in cybersecurity, and I said, we're interested in industrial controls. You know, let's do this. I've come here, I've learned a lot. It's been great. This morning is to continue the learning, a little bit different style. You have the, okay. So I want to talk to you a little bit about the approaches we're doing to look at the ecosystem of cybersecurity. And I think this is important to try to break down the language a little bit, because we have days now of cybersecurity discussion, and I think it's been very good. But when it comes down to it, you really have to sort of break it down as to what are you talking about. I'll give you a perfectly good example. On one end of it, we look a lot at the zero-day market. 0 days are vulnerabilities in the wild, undiscovered in the wild. They're the most dangerous. They're the things that both the offensive and defensive folks want to own. Defensive might be the software vendors who have the 0 days in their software. They want to get those and patch them and fix them. Offensive could be black market, criminals, could also be, well, it's called gray market when it comes to governments, but governments also buy these, well known, they buy these 0 days and store them. So at the very end of it, if there aren't any of those, you all are a lot safer. I mean, there's still problems. You haven't patched your systems. That's a management issue. As we all know, humans are probably 90% of the problem, but you know, we still need all of us. But we're still 90% of the problem. But on one end of it is this vulnerability issue. And when you look at vulnerabilities and the patching and so on and so forth, you really have to know who you're talking to. It's quite interesting. The statistics are patches, 80% of patches remain undone or 60% undone on software, say, for up to a year and so on and so forth. But if you talk to a platform vendor like a Facebook or a LinkedIn or whatever, that's not true. They patch these things right away. You talk to, you know, Windows with this, you know, Microsoft with distributed software, it's a different story, especially some of the older versions now that we're seeing that are no longer supported. So you really automatically have to break down your conversation. Am I talking about vulnerabilities in, you know, platform software? Am I talking about them in distributed software? Is it older versions? Is it newer versions? Is it automatic update? Where are those 0 days being found and how are they being patched? So everything gets very specific quite on that end of it. On the other end of it, and you all have seen this in the news, I don't have to bring them up, but during the conference people talked about, you know, the differences between how Home Depot and Target handle things. I view the Sony situation as a total debacle in the public relations domain. I think both the government, who attribution of another country is hard. So the getting to the point where you blame North Korea is a hard thing. To sort of do it and have as much doubt in the newspaper all based on arguments over a bad movie sort of waters the whole thing down terribly. So I don't think it was a very good, I don't run the country, so I don't want to make too many judgments here. I think that's a hard problem. But I do think that that was a debacle on that end. And then the whole business of when it was released and, well, also following up that with the various press conferences on attribution. So today we're all left, I mean, how many people today are sure it's North Korea because of what the government said? 2, 3. That's not, you know, that's, I mean, that's exactly what, you know, can go wrong. So we look at both ends of it. I'll talk a little bit about how we model now just one particular aspect. I'm going to look a little bit at the relationship between software quality and patching, but it doesn't have to be about software quality and patching. It can be just as well about you know, the equipment and industrial controls in the field and the maintenance and the purchase of new some of the things I saw in the other room that harden systems and that affect things, and investments in those and what they can do by trying to move things up front rather than trying to chase your tail. I started in cybersecurity work when about, is it 6, 7 years ago, was a major effort. I was working with a Frank Kramer who was supposed to become the czar. In the end, someone else was chosen in Obama's first term. But it was all about the power of telecommunications and electrical grid at that time, and finance at that time. But the common thread was everyone was chasing their tail. And so you can do things upstream, or you can patch and try to catch up. So this was a start of trying to catch that type of analysis. So what we want to do in this effort is understand this ecosystem and look at it from a management point of view. I'm going to suggest that there's several questions that are not just technological, behavioral, managerial. Those are the things we consider in our work. We believe that these can be well captured in a modeling framework. The cyber dynamics can be unpacked and put into a model to understand. The modeling that we're using is called system dynamics, which captures very nicely systems behavior, but also human behavior. It is based on control system theory, so that ought to be familiar. It captures feedback loops. It's as simple as the flow of water in and out of a bathtub, and then putting many bathtubs together. And the insight of the person who originated, Jay Forrester, to some extent, is humans can think about feedback loops between 2 bathtubs, maybe 3 bathtubs. Beyond that, we're pretty much, you know, topped out. We have applied this in a number of domains. We've looked at crisis and threat in oil markets. We looked at stability, instability in countries. We've done some work looking at, James and I have modeled some situations looking at the relationships among narratives in society and violent activity. We've integrated with that large data sets looking at social media. We've taken a look at hospital improvement and the introduction of new technologies. There's a range of projects that we've done, and there's a set of literature looking at many of these things. What it helps us find, and this is what people are looking for, are the existence of unintended consequences due to certain actions, and unfolding situations of worse before better, or better before worse, where you think things are getting better, and in the end you don't know that they're going to get much worse. So let's take, and this can be any setup of systems, but let's look at a world where we have these boxes are called stocks, and they're just a collection of systems, say in your organization or in a particular plant. And your systems are at 3 states. There's systems not at risk, clean, no vulnerabilities, no issues at all. There are a set of vulnerabilities that might come in due to adverse behavior, management, software, so on and so forth, that puts your systems at risk, and you understand that movement. And basically anyone, this is the old saying, anyone who believes their systems aren't at risk, is wrong. I mean, where you only have two states, those have been attacked and those that are at risk. But we have here systems that are not at risk, and hopefully we can bring some of them to that state. And then finally, with the systems at risk, you take that vulnerability that you have, and this is what happens in the world. You take your 0-day, you take your vulnerability, you build an exploit, and some attacker actually is able to attack it. And we know some information from various reports. This is from a Verizon data breach report. We know similar information from other reports. 80% of breaches had patches available for more than a year. This is again true more of distributed software than I've just described in the case of a platform software. So a very different world, and again, we'd have to apply it to some of your environments. 67 were aided by errors with the victim. So these are, and I think that number is considered low. That is things that people do wrong inside your organizations. So I think that number is maybe even low. Yeah, certain percent use malware, a certain percent of some of these numbers I think you've seen over time. But they laid on this chart, they give you an idea of what enabled things to move from systems not at risk to affected or compromised systems. So one of the key questions is, what is the controlling rate of change and how can we be more anticipatory than reactive? And the arguments have always been, and we'll get to that, is we want to be able to do this. And unlike, I was on a panel yesterday, which I thought was incredible, but I really want to see more CISOs, more CEOs with this we're willing to spend on cybersecurity concept and go through with it. What we see here is a good, in the end, is a good argument using a model that helps justify those expenses up front rather than on the back end. And that's what we were really striving for, is something that can be delivered to those people because of the management aspect. It helps the technical people understand they'll be in better shape, but also helps the management folks understand that they will be also. So the kinds of situations that we're looking at in this model, and again, the names have changed, but they're exactly identical. I did this a little bit just to give you an idea of what is going on. Again, your not compromised are your systems that are fine. Your identified attack vectors are ones that have vulnerabilities that someone understands, and the compromised are your systems that have been exploited. And you look at situations where there are attackers out there, and they get greater capabilities, they identify exploits, which increases the number of identified attack vectors, which the firm has some knowledge about this, starts to understand. They do some patching of these identified exploits, that is the vulnerabilities that we've talking about. The identified attack vectors go down and the non-compromised go down. So this is the good news about doing things upstream. We sort of bring things, things get a little out of hand, but then we bring them back. All of this, of course, involves what is the timing between these things. Obviously, if you wait a long time to patch, you give your attackers a lot more time. And then there's an additional problem during that time, is that you've released a patch which can be reverse engineered by other attackers. The reverse engineering now allows them to learn more. As long as you remain unpatched, they now have access to a vulnerability. Please. Yes, please. Oh, yeah.
I'm looking at that. One thing I don't see it more, I'm interested somehow.
Yep.
Constraints when you talk about patches. There's certain different situations and different constraints. I'm sure you.
Yeah. So let me. There are many aspects of this modeling approach. What? Oh, I'm sorry. Yes, they said to me, make sure that I at least repeat the question here. So the question was about, are the constraints represented in the model, and what types of constraints are mentioned, and to some extent I'm going to say it depends what kind of question you want to answer and whether it really matters. So there are models that can prove and show relatively insightful things and teach them that have very little data and very few constraints. And then there are models that have been used to determine whether a contract over multiple years between the US government and a shipbuilding industry went over budget because of the shipyards or because of the government, and it has pages and pages of models. So it always have we always sort of have the KISS thought to it. Start simple and then move on. I'm trying to, in this case, trying to answer the one question about what's the difference between doing things upstream and doing things downstream. So I'm just doing a general principle. I'm applying some constraints, but probably not to the point that you do, because I don't, in a way, need them here. So that's the difference. But as I ask different questions for which those constraints are important, or endogenous, we say endogenous to the system, then I need those constraints. Okay? Yeah. Yeah.
I understand some words. That's one of the distinguishing things that always comes up.
Yeah. He said I'm going to have to get strict about this. Yes.
I'm sorry, and I don't.
You will go to the microphone.
Hello.
Yeah.
You can hear that? Oh, no. The only reason I asked the constraint. I mean, I don't want to, certainly don't want to complicate anything, but it's just that when you talk about something as patching, like, as soon as you say that word, that term in my world, the industrial world, we all know that there's enormous constraints on patching. So to talk about even a strategy about like what's the timing of your patching and that, you can't do it. Now I understand that raises the issue. I mean, that's why I was asking. The constraint says, well, we can't do this, so therefore that is one.
And I'll give an example.
Anyhow, that's why I asked.
I'll give an example of exactly what you said, which I learned here. I learned this the first day. I learned that there are plants that you work with for which there are perhaps no one working there anymore who knows how to shut down the plant because it hasn't been shut down for 25 years. And so, I don't know if this is true, but this is a fact I heard or something someone said fairly early on. So when you think about patching and you think about the possibility of, well, let's shut things down and patch it. With a piece of software, it's relatively easy to do, though, again, the uptime availability of most of these platforms, but they've solved that problem. But in your distributed environment, you don't just shut down a plant and patch everything. So it's a great point. We move, when we want to answer in a certain environment, we make the model specific to that. It's a great question, great question. So the other thing that we're trying to avoid, which we see so much of, is the downstream, and I won't spend a lot of time. The downstream is the attackers have identified vectors, they compromise systems, you have compromised systems, the performance of the firm goes down, availability, data security, access, this is your breaches that have been in the news. The company does some remediating, the number of compromise go down, that's good news. But the remediating and the number of identified attack vectors goes up, actually, because the remediation itself helps identify those attack vectors and make more people aware. More defensive procedures cause the compromising to go down, even though the attackers have become more aware. And it really depends on this relationship, again, between how quickly you can do the remediation versus how quickly they get a foothold into your system. So again, the most important thing to catch from this is there are downstream dynamics and there are upstream dynamics. So in order to capture this, we build models, and I'm not going to go detailed into the iconography. James will give you modeling 2 and modeling better. So I'll forward that to your part. What I did want to show here is that this model had some components. You see your not compromised, identified, compromised part. You see the attacking component of the model. You see the patching component of the model. And here you see the software security, and this represents, to me, in the case we were doing it initially, and it represented less releases of higher quality software. It could just as well mean or could be replaced by, better in-plant maintenance, hardened controllers, those types of things that you do preventively. And so we able to run some tests, assuming some increase in vulnerabilities or awareness of vulnerabilities. We're able to look at 3 types of systems, essentially a base case where nothing happens, sort of uninteresting, a red case where we improve the quality standards and we do our patching, and a green case where, which is more or less what's common today on distributed software and what you see in the issue of, patches were available for over a year type of thing in the earlier slides. And so for technical people, going back to the blue line is the desired thing. You want to reduce your number of compromised systems, and you can see the red line goes back there and the green line does not. For managers, they want to look at the upstream costs of what it costs to do this in advance to prevent these from happening. But ultimately, for senior management, you want to look at the total costs. And so down here, this is your argument about, and this is measured in weeks down there, this is your argument, pretty clean, pretty simple, upstream costs less than downstream. Not rocket science, but it's something that you can model, you can configure to your specific situation. So if the question is great, if I want to go into something very specific, an environment in industrial controls where I can't do the patching or can't do certain things in certain time, I can put those time delays in the model. I can make this specific to an environment, and I can create the same type of graph, which may not show the same results for that type of environment and run it under different situations. So solving upstream, and again, I'm not looking for changing the world in many, many steps. I just want to be able to communicate to every level of person how this affects things. And so doing this modeling for me, showing graphs like those, helps me to communicate that upstream is more effective than downstream, that differentials in time delays are significant as far as affecting these. And what we haven't shown here, because we just did run of the model and didn't look at certain situations that can cause behavior, is that there are nonlinearities that can cause tipping points or more exponential behavior or exponential behavior, which we haven't seen as a result here. And those would be in another talk. So from a project point of view, we do believe it's a holistic approach. That's sort of understandable. I mentioned that we're looking across all aspects of it. And we looked at the timing and so on. And bug bounty programs, vulnerability markets, understanding the supply of researchers, people who are looking at these things and how many they are and how they can affect us on security and the cyber ecosystem, well, that you have to stay tuned for James's talk in about 45 minutes. All right, any questions here? We will have a panel after we have another talk coming up by Key Holmes. We'll have another talk. Any other questions that you have right now? All right, great. Key? You.